Welcome to Exponential Smoothing and Holt-Winters in Python. In this lesson, you will learn to forecast time series data using easy and powerful methods. What is exponential smoothing? How do you handle seasonality and trend? How to use real-world datasets for forecasting? Let us get started step by step. Running the cell now. We import warnings to hide any warning messages, so our notebook looks clean. We now bring in useful libraries. Pandas helps us work with data. NumPy does math. Matplotlib lets us draw charts. Pandas lets us load and look at our dataset. NumPy will help with number crunching. Matplotlib is for drawing nice visualizations. The setup is ready. Running the cell now. Try typing out the import lines as practice. See if you get any error or warning. What is exponential smoothing? Exponential smoothing is a method for predicting the next value in a series. It gives more weight to recent data points, so your forecasts respond to changes quickly. This is very useful in real-life data, like sales, temperature, or demand over time. Running the cell now. Now we will download a real dataset about shampoo sales. We choose the shampoo sales dataset, which contains real monthly sales numbers. Let us load it from a public link. We print its size. Rows mean months, columns are details. We take a peek at the first records. This checks our data loaded correctly. Running the cell now. See if you can spot the column with sales numbers. We want to see which columns are available to use. Printing the list of columns helps us find the sales values. Running the cell now. Which column looks like it could contain the sales amount? Let us draw the sales numbers to look for patterns over time. We make the plot wide for easier reading. We plot the sales column with dots for each data point. We add a title so we remember what we are seeing. Labeling the x-axis helps us track the months. Labeling the y-axis tells us these are sales numbers. Adding a grid makes it easier to see trends. We display the plot. Running the cell now. Do you notice if sales go up, down, or have a repeating pattern? Why smooth data? Raw sales data jumps up and down. Smoothing helps find the real pattern. Exponential smoothing is like forgetting old noise. You can use it to prepare for holidays or busy times in business. Running the cell now. We will try simple exponential smoothing. StatsModels is a Python library for statistical models. We import its smoothing function. We convert sales values to numbers to avoid errors. Next we create a model using our sales data. We fit the model. The parameter sets how much weight each new value gets. The model gives us smoothed forecasted values. We plot the real sales. We plot the smoothed line, in red, to see how smoothing works. We add a legend so we know which line is which. We provide a title for our chart. We display the chart. Running the cell now. Try changing the smoothing underscore level value and see what happens. How does smoothing work? You just saw a smoother line. Exponential smoothing uses a smoothing level. A value near 1 follows recent data closely. A value near 0 is smoother. You can adjust this to suit noisy or calm data. Running the cell now. Let us try a very high smoothing level. We fit the model again with a setting close to 1. We get new forecasted values. We make a new plot. Plotting the real sales again helps us compare. Here is the very high smoothing line in green. The previous smoothing, in red, uses a lower value. Legend helps us track which is which. Another title to make things clear. Show the plot. Running the cell now. Notice which line follows their ups and downs more closely. What about trend and seasonality? Simple smoothing is not enough if data grows over time or has repeating seasons. You might see sales increase every year or every holiday month. That is where Holt and Holt-Winters methods come in. Running the cell now. The Holt method adds trend handling. Trend means steady up or down movement. We import the advanced smoothing function. We build a model that looks for a trend, but skips seasonality for now. Now we fit this model. It tries to find the best settings. We get the new trend-aware fitted values. Let us plot again. Original data for comparison. The purple line shows how Holt smoothing handles a trend. A legend tells us which is which. The title tells us we now see trend smoothing. Show the results. Running the cell now. Try to spot how the purple line is better at following steady rises or drops. Next, we add seasonality to our smoother. Seasonality means repeating cycles, like months or holidays. We set up the model to look for both trend and seasonality and tell it how long a season lasts. Now our model learns both features from data. These new forecasts are trend and season aware. We plot again. Original sales check. Orange line adds both trend and repeating patterns. Legend notes which is which. Title tells us we use both trend and seasonal smoothing. Running the cell now. Does the orange line capture both steady rises and repeating bumps in the data? Quick recap: 3 layers of smoothing. Simple, just smooths, ignores trend and cycles. Holt adds line up or line down trends. Holt-Winters adds cycles, like holidays or seasons. You pick based on what your data looks like. Running the cell now. Let us use our seasonal smoother to look ahead. We ask the model to predict 6 future sales values. Print a message saying what we are forecasting. Print the forecasted numbers. Running the cell now. What could these forecasts help you decide in business? We will make one chart that compares real, smoothed, and future values. Set figure size for clear view. Blue line is actual past sales. Orange line is the model's fitted results. Green dashed dots are our future forecasted points. Legend labels each line. The title reminds us what we are looking at. Show the plot. Running the cell now. This helps see if the forecast continues the pattern. Sometimes, data files have missing spots. Checking for missing values is a safe habit. Running the cell now. Try deleting a cell from the CSV and see what changes. If a value is missing, we can fill it in with the last available sales value. We create a new copy, filling gaps forward. Now, check for remaining missing values. Running the cell now. Notice the missing count is now 0. Let us make an interactive forecast. Ask the user how far into the future to look. We turn the answer into a number. We use our trained model to predict as many months as the user asked. Print a message saying this is the forecast. Print the results. Running the cell now. Try forecasting different numbers of months to see how the numbers change. Let us see what happens if we try to fit a model with empty data. Start a try block to catch errors safely. Try to make a model with no data. This is just for learning. Try to fit the empty model. It is expected to fail. Catch the error and print what went wrong. Running the cell now. Try using an empty list in your own model and see what error message you get. If you want to reuse your model later, you can save it to a file. We import Python standard saving tool, called Pickle. Open a file in write mode. The WB means write binary. Save the fitted model object. Print a message letting us know it worked. Running the cell now. Try loading your saved model in another session. Now it is your turn. Choose a smoothing level. Ask the user for a value between 0 and 1. We convert it to a number. Fit the smoothing model using their choice. Say these are the user-generated results. Show the first few smoothed values. Running the cell now. Try a low and a high value and compare. Recap, what have you learned? How to smooth out sales data. How to spot trend and seasonality. Using Holt-Winters for forecasting. Handling missing data. Making predictions for real business planning. Practice with other datasets to get better. Running the cell now. Want more? Subscribe for new lessons. Try using exponential smoothing on other datasets. Share your charts in the comments below. Subscribe and turn on notifications for more tutorials. Running the cell now. What other time series data would you like to forecast? Let us know.